All right, welcome everyone to demo number 2. This demo, we're going to deploy an EC2 instance similar to what we did in demo number 1, except this time we're going to do it with Terraform infrastructure as code. As a bonus, we're going to demonstrate an application load balancer and an auto-scaling group and sort of show you the self-healing capabilities of this multi-node EC2 instance cluster. Okay, so Terraform. Terraform is infrastructure as code. You write down, you define in code how you want your infrastructure to be, and then Terraform sets out and goes and creates it. It also will compare it with what's actually there and make any changes as required. So I'll just start with some of this boilerplate here. Main.tf, there's a couple things required to get Terraform workspace going. First, we've got provider AWS. That just tells Terraform that we're going to be working with AWS. Pretty self-explanatory. Role ARN, so this is a role that I'm going to get Terraform to assume. This role I've already defined in my own AWS account, TF automation user. It has the necessary permissions to deploy in this account and environment. I've also defined account ID as a variable. Obviously, I didn't want to encode my own account ID for security reasons, so I've opted to use it as a variable. I've embedded it into my terminal in the environment. You can do that too if you want. It's just you just go export tfvar. Tfvar is just the prefix required for all Terraform variables, and then account underscore ID, and then you type in your account ID here. Right. Okay. Terraform. This Terraform block just we've got to declare where the state is stored. So Terraform state is how Terraform uses to keep track of what it thinks the infrastructure is actually like. It has to compare the state with what is actually out there. This is how Terraform manages the various components of the infrastructure. For the purpose of this demo, I'm opting to use local state, meaning it's going to store all the state locally on my disk drive. That's pretty terrible practice in reality. In reality, you really should be using something like S3 or GCS, storing your state in an area where it's commonly accessible. State should not be stored on someone's local machine. That's just bad. Okay, moving on. EC2. I'm going to uncomment this block here because we're going to need it. So two things I want to show you, two blocks rather. So we've got the resource block here on the bottom, and we've got the data block here on the top. So I'll start with the resource block. A resource block tells Terraform to go out and create a particular resource. There can be resources like AWS instance that you see here, or it could be something like an auto-scaling group. Anything that you can create in AWS would be considered a resource for the most part. Up here, we've got a data block. Data goes and searches for something. So in this case, we want data to go search for AWS AMI with the name of Ubuntu Bionic 18.04, blah, blah, blah. And also we want it to select the AMI that has the owner as this account ID. That's just the account ID of Canonical, the maintainers of Ubuntu. All right, so some attributes here in the AWS instance. You've already seen this from the deployment in the previous demo. We've got the AMI ID that you can see data AWS AMI Ubuntu.id. That's just the ID that's discovered by this data block. We've got some other things too. The instance type T2 micro. We've got the VP or the subnet ID, and we've got the VPC ID. Don't worry about the subnet ID and the VPC ID. You will have to provide Terraform. You have to tell Terraform where to deploy this instance because like AWS won't let you deploy into something if you don't have a VPC. You've got to deploy it into something. Don't worry about defining the actual VPCs and the subnets. That's for another video. If you're curious, you can look into this vpc.tf file where I've defined it, but it's honestly a lot, and most of the times this is sort of an IT job. It's also sometimes an SRE job as well. But for the most part, it'll already be set up for you, and you shouldn't have to define it in most organizations. All right, user data. This is an important call out because user data is an AWS construct which allows you to pass in shell scripts, a shell script to your instance that will run during provisioning. So all that stuff that we had to do on the command line in the previous demo where we were installing the required Ubuntu packages and cloning the Git repo, you can automate that with a shell script. I'm going to go into userdata.sh here, and you can see these were all the steps that we did before in the last demo. So now we're going to pass it in as a script. That way we don't have to do all that manual typing. So we are just about ready to deploy this instance. I'm going to go, I'm actually going to go into my other window. So this is my Docker environment. I like to use Docker because I can tear down and spin up environments as need be. All right, so I'm just going to paste that here. I'm going to go terraform init. It's actually already initialized. I'm just typing it here for demonstration purposes. Terraform init just creates the workspace here in your local directory, and it downloads the AWS provider that's necessary to communicate with AWS. All right, so now we can go terraform plan. So what terraform plan is going to do is it's going to look at all of the terraform files in the current directory and then compare it with what is actually real in the AWS in the AWS cloud right now. So you can see here 1 resource to add, 0 to change, 0 to destroy. If you want, you can scroll up here and you can see all the additions, the changes. There are these icons here. So it's pretty cool. Terraform has just said, okay, there's 1 resource to add. So we're good with that. I'm going to go terraform apply. Now, since I've already reviewed the plan and I know it's good, I'm just going to add this flag called auto approve. So I know it's good. So Terraform is going to set out and create this resource for you. None of that manual stuff that you had to do in the previous demo that took a total of 6 minutes. This one step will take about 30 seconds. While we're waiting for this, I'm going to hop over to the VPC diagram because I really want to show you what we want to do in the next step. So this is our VPC. You see on the outer box, that's our VPC. Within the VPC, so the only way to get into the VPC is through the Internet Gateway. I've already created that. Don't worry about it. The Internet Gateway is the portal to the internet, and traffic's got to pass in and out of that. If you don't create an Internet Gateway, you won't be able to access the VPC from the outside internet. So inside we've got the application load balancer. The application load balancer is awesome. All traffic comes through is routed by the application load balancer, and the application load balancer will actually figure out which instance to route traffic to based on CPU load. If an instance goes down, then the ALB will route traffic to the other instance. It also is in contact with the auto scaling group, and if it is determined that the instances are getting too overloaded, too overwhelmed, the auto scaling group has the ability to spin up new instances in either the existing subnets or in other subnets. So it's quite a powerful tool. So what we can end up with is a multi-node setup in this ALB cluster. What you don't see in this diagram is the launch configuration. The launch configuration is the template by which instances are created. I'm sure by now the instances our deployment is complete, so I'm going to go back here. Yep, apply complete, resources added. So I will just show you really quickly here. I'll come over to the instances tab, hit a refresh. So there's our instance, BCS hacks EC2 instance. If I go into ec2.tf and go into the AWS instance resource, there's that name that I defined. So perfect, it's running our little web server. If I go into a new tab and paste this, and there's our app. It's showing us our our picture. Perfect. So that's good. I'm actually going to destroy this instance, but well, we actually won't worry about that. Before I talk about I'm going to talk about the terraform. Oh no, actually no, I changed my mind. I'm going to show you from within the AWS console. Okay, so from within the AWS console, I'm looking at the application load balancer. I've actually already deployed this because this deployment takes a number of minutes. There's so many components that are required, spinning up the VPC, the subnets, the gateway, et cetera, et cetera. So it took way too long. So I've already done it. So here's the load balancer. Load balancer has a listener, and the listener is connected to a target group. So if I go, I'm going to open this up in a new tab. Apologies, my computer will take a bit of time to open this. All right, so there's target group. Target group occasionally runs health checks on the instances. There's our 2 instances that I've configured, and if any of these instances become unhealthy, it's going to terminate them. I'm also going to open up the auto scaling group and show you briefly the auto scaling group. The auto scaling group just defines the capacities that we want. So the capacity just means the number of nodes. And we've got a launch configuration down here. Launch configuration kind of specifies the template by which we want to launch our instances. That's the AMI, the Ubuntu 18.04 AMI. The instance size. Okay, so I'm going to point towards the Terraform itself, because that's kind of how we want to configure these things. We don't want to have to do all these different steps manually. So this is what a typical ALB Terraform file will look like. So you've got the ALB, you've got the load balancer target groups, so that just connects the ALB with the ASG. And then we've got the listener, like you saw earlier. The listener connects the target group with the application load balancer. Moving over to the ASG, so we've got the ASG. I've defined the min size to be 2 instances, max size 2 instances, desired capacity 2 instances. You can add additional configuration to the auto scaling group to tell it to spin up instances if CPU is getting too high or memory usage is getting too high. You can customize a whole host of things, and also alarms for that. And there's the launch configuration. I've done something a little bit different here. I've told instances that are created by the launch configuration to use a special security group. Security groups is a whole nother conversation. I don't want to get into it because I'm very cognizant of time. I'll just say in short, the security group says that these instances cannot be accessed from the internet. They can only be accessed by the application load balancer. And then the application load balancer has the ability to talk to the internet. So that's that in a nutshell. All right, so I'm going to go into the auto scaling group. Unfortunately, what I wanted to do today was to demonstrate the killing of an instance. And I will, but I won't be able to demonstrate the self-healing that well. What I am going to show you here is if I go into details and I just edit the desired capacity to 3 and hit update, this will take more than a few seconds. If I hit refresh, it's not going to show up right away. If you come back in about 20 seconds, you'll see it start to launch another instance. But what I could do is click on one of these instances and just terminate it. The auto scaling group, unfortunately, is a little bit slow to react. It takes about a minute for it to realize, because it doesn't do a health check every few seconds. It can take up to a minute for it to health check and realize, oh shit, this instance is no longer healthy. Let's spin up a new one. I'm going to go back to activities, see if, okay, so there, now you see a message launching a new instance. This was because I changed the capacity to 3. And so pretty soon, if I come back into here, there, now you see a third instance. It's terrible that it says all instances are healthy because it's not really the case. One of the instances is actually dead. I think it was this one. Oh no, that one's running. I hope you get the point. Yeah, it's this one, terminate. So the purpose of showing that is that the load balancer here, for your customers or your users, all they really care about is the DNS of the load balancer. The instances themselves are abstracted away from the customers, and the auto scaling group will take care of healing them if some of them become unhealthy. The only thing that your users care about is the load balancer DNS, and you can see that this continues to work. It's awesome. If for whatever reason this instance gets terminated, and we are left with only one instance, it'll still continue to work. The load balancer will seamlessly switch between instances that are working, and your customer will never notice a thing. So I'm not going to sit here and wait for the auto scaling group to figure out that there's something wrong. Oh, see there, now it's figured out one of the instances is unhealthy. That was a result of it failing a health check. But I hope you get the idea from today's demo. Having auto scaling groups and load balancers is a really powerful tool in your arsenal. And more importantly, infrastructure as code, you should be deploying infrastructure using something like Terraform because it's deterministic, it's much faster, it's much less painful. It's just a much better experience overall, and you can commit it into Git. That concludes my demo for today. Hopefully you have taken something out of it. I know it was a bit of a fire hose of information. The repo is going to be available on my GitHub, so feel free to take a look at the files if you'd like. Thanks for attending today.